Hello friends, myself dnyandip and today we are going to learn the standard physics topic, that is the reflection of light. Now in the reflection of light we see the word that is a light. Now what is the exactly the light means? Light is nothing but the electromagnetic radiation. Now what is the electromagnetic radiation means? Light propagates or passes in the form of the wave. Now which type of the wave? That is the electromagnetic wave. Now, what is the exact meaning of electromagnetic wave? That is, in this wave, the electric and the magnetic words we have seen here, that is, electric and the magnetic. These two components are perpendicular to each other in this radiation. That's why we call the light is nothing but the electromagnetic radiation, which propagates in the form of the wave. Now, which type of wave? That is a transverse wave. Now, this is the basic concept of the light. That is, the light is electromagnetic radiation. Now, what is the electromagnetic radiation? The radiation or the wave in which the electric field and the magnetic field are perpendicular to each other. Now, which type of the wave? That is a transverse wave. In the previous chapter, we have seen that the sound, that's the wave of the sound, is longitudinal wave. Here, wave of the light is transverse wave. You have seen the difference between the transverse wave and the longitudinal wave. That is the vibration of the particle. When the vibration of the particle is in the same direction as the propagation of the wave, then the wave is called as a longitudinal wave. When the vibration of the particle is perpendicular to the propagation of the wave, then the wave is called as a transverse wave. So, whether it is a longitudinal wave or the transverse wave depends on the vibration of the particle. Now, longitudinal waves. So what is the basic information about the light? That the light is the electromagnetic radiation. Now electromagnetic radiation means the radiation or the wave in which the electric and the magnetic field are perpendicular to each other. We call that is the electromagnetic radiation. Therefore the light is a electromagnetic radiation. And which type of the wave of the light is? That is a transverse wave. Now light. Consider in a dark room, when we switch off the light, then we are unable to see any object. This is because the phenomenon, that is the reflection of the light. Consider this is a pen. So we see the color of the pen is white because this pen reflects the specific wavelength of the light, that is a white in color. That's why the color we see, the color of this pen is white. So what is the wavelength? What is the frequency? What is these two characteristics which is important in the reflection of the light? Now you know that the visible range of the visible range of the light means our human eye, or we are able to see only the range, specific range of the light. That is the specific range of the frequency and the specific range of the wavelength. Means, and the specific frequency is that the wavelength, the light between the 400 to the 800 nanometer of frequency is visible to our eyes, and in the wavelength, and in the case of the frequency, that is the 400 to the 800 terahertz frequency is visible to our eyes. This is the range of the visible light. Now, as we know that when we pass the beam of the light through the prism, then we get the 7 different colors, that is from violet to the red. Now, what is the wavelength of the violet? Then the wavelength of the violet is a 400 nanometer and the wavelength of the red light is 800 nanometer. So, this is a visible spectrum of light. Means, we are able to see only the light between this range of the frequency and between this range of the wavelength. Now, what is called as the what light should call which is have the below 400 or the below the wavelength range of the violet color? This is nothing but the ultraviolet frequencies, and the range of the wavelength which is greater than the red color, then this is called as a infrared frequencies. For example, the frequency of the red light is 800 terahertz. Then the frequency of the light having or the more than 800, then we call it as a infrared radiation. And for example, the frequency of the violet color is 400 terahertz, means the frequency which is lower than the 400 is nothing but the ultraviolet radiation. So this is the visible spectrum of our light. you have seen the light, that's the electromagnetic radiation and the visible spectrum of the light. We have seen the characteristics of the wave, that it's a transverse wave and it's an electromagnetic radiation. So now let's move towards the exact our topic, that's the reflection of the light. Now how exactly the reflection of the light takes place? That is, when we switch on the light in our room, then we are able to see the different objects. This is because when we switch on the light gets reflected from the different objects. Now how it actually works? Here is the diagram, that's the reflection of the light. That's when we switch on the light, that's the light falls on any surface of the object. Consider this is the mirror, means this is the any surface of the object. When we switch on the light, the incident ray falls on that surface and get reflected back, and this reflected rays falls on our eyes, and we are able to feel the sensation of light, and we are able to see that specific object. Now how the laws of the reflection works, or how actually the reflection works. In the reflection, there are only the three laws of the reflection are important. Now in the reflection, there are only three concepts, that is the concept of the incident rays, concept of the reflected ray and the normal. Now when the rays falls on the subject at a certain point, this point is called as a point of incidence. So this is a point of incidence. When the ray falls on that point, it gets reflected back from that point, and this ray is nothing but the reflected ray. Here the ray AO is the incident ray. Ray AO is equal to incident ray, and angle I, that's the angle made by the AO and N, is nothing but the angle I, which is nothing but the angle of incidence, means AO N, this angle is equal to angle of incidence. Now what is the angle of incidence? The angle made by the incident ray to the normal is nothing but the angle of incidence. And what is the angle of reflection? That's the NOB. This angle is nothing but the angle of reflection. That's the NOB. This is the angle of the reflection. Now let's move towards the what is the NO. NO is nothing but the normal. NO is a normal. Now this is the phenomenon of the reflection of the light. That is a light incident on a certain point, and it gets reflected from that point back towards our eyes. Now what is the law, or how this specific incidence or the reflection of light takes place? That's the laws of the reflection. There are only three laws of reflection. That is the angle of the reflection, means this is the angle of the reflection. The angle made by the reflected ray to the normal is nothing but the angle of the reflection. The first law of the reflection is that this angle of the reflection is equal to the angle of incidence, means I is equal to R, means angle of the incidence is equal to the angle of reflection. Now let's move towards the second law, that is the incident ray, reflected ray and the normal lies in the same plane, means AO, this is the incident ray. When it falls on the certain point, that's point O, this is point of incidence, and gets reflected back, that's the OB is the reflected ray. This AO means incident ray, OB reflected ray, and the NO, this is normal. This incident ray, reflected ray and the normal lies in the same plane. This is our second law of reflection, that the incident ray, reflected ray and the normal lies in the same plane. Incident ray, reflected ray and the normal lies in the same plane. Now let's move towards the third law, that's the incident ray and the reflected ray are on the opposite sides of the normal. Now this is the normal. The incident ray is on this side and the reflected ray is on this side, means the incident ray and the reflected ray are on the opposite sides of the normal. This is the third law of the reflection, means incident ray and reflected ray are on opposite sides of normal. So this is the normal, and this is the AO is the incident ray and OB is the reflected ray. So what is our third law? That is the incident ray and the reflected ray are on the opposite sides. There are only the three laws. It's very easy to understand. That is, the incident ray and the reflected ray are equal. Means the incident ray I is equal to the R. For example, if this angle makes an angle of 40 degree, that the angle of incidence is 40 degree, then the angle of R is also the 40 degree. Means when the angle of incidence is 40 degree, the angle of reflection automatically makes that 40 degree. This is the first law of the reflection. Now what's the second law? The incident ray, reflected ray and the normal, the three of these are lies in the same place. This is our second law. Now what is our third law? That the incident ray AO or any incident ray and the reflected ray are opposite to of the normal. This is the three laws of the reflection. Now let's summarize what we have studied till now. That's the light, reflection of light. For the understanding the reflection of light, we have to understand what is exactly the light. What is the light? Light is nothing but the electromagnetic radiation. Now what is the electromagnetic radiation? Electromagnetic radiation means it propagates in the form of the wave. Now one important point is that it does not require the medium for its propagation. That's the electromagnetic wave does not require the medium for its propagation. That's why we are able to see the light coming from the sun, because in between the sun and the earth there is only the vacuum is present. There is no medium. So electromagnetic radiation does not require medium. The electromagnetic radiation doesn't require medium for its propagation. Now what is the light? Electromagnetic radiation. One theory also says that light propagates in the form of the photons or in the energy packets. Light propagates in the form of the photons or the energy packets. Now light is electromagnetic radiation. It is form of the wave. Which form of the wave? That is the transverse wave. Okay. Now the speed of the light in vacuum is 3 into 10 to the power 8 meter per second. This is the speed of the light. Now we have seen then the spatial frequency or the spatial range of the visible light. Means we are able to see or visible the specific range of the light, which is between which frequency? That's a 400 to the 800 nanometer, and wavelength that's a 400 terahertz to 800 terahertz. In between this we are able to see this visible light. Now it starts from the violet color and ends at the red color. Means the 400 nanometer is the frequency of the violet color and 800 nanometer is the frequency of the red color. The frequency above red is called as infrared, and the below violet is called as ultraviolet. Now what are the reflection of light? Whenever the light gets reflected back from any surface, this is known as the incident. This is known as the reflection of light. Now for the reflection of light, specific law must be followed. Now which law? That is the where the incident ray and the reflection ray are the same. Means the angle of the incidence and the angle of the reflection. The angle of incidence made with the normal is equal to the angle of the reflection which made with the reflected ray. This is the first law of our reflection. Now what is the second law? The incident ray, the normal and the reflected ray are lies in the same plane. Okay, this is the second law. And what's the third law? The incident ray and the reflected ray are on the opposite sides of the normal. This is our third law. Now this is the reflection of light on the regular surface. That is the reflection of the light in a regular surface. Means the surface is regular. Here we have taken the surface of the mirror or the plane surface. That's why it is the reflection of light in the regular surface. Now what is the reflection of light in the irregular surface? For example, consider this is a surface. So if we consider the various rays of light which is parallel to each other are falls on the regular surface, then it gets reflected back and follows the law of reflection. Means these rays which are incident on the surface are parallel to each other. Means consider this is a PO, this is a QO. Means P, this is the PO, it's a QO, and this is the AO. These are the three incident rays. On the regular surface, these three incident rays are parallel to each other, and also the rays which gets reflected from these rays are also parallel to each other. Means the rays of the incidence and the rays of the reflected, these rays are parallel to each other. But in the case of irregular surface, in the case of the irregular surface, when the rays fall on the irregular surface, it gets reflected, and the ray which is parallel to the incident ray these two incident rays are not parallel to each other, and these two reflected rays also are not parallel to each other. This happens in the case of the irregular surface. Now let's see the reflection of the light in the irregular surface. The three laws of the reflection, we have the three laws of the reflection, and consider it is the reflection of the light on the irregular surface. Now consider this is our irregular surface. When the incident ray fall on this point, at the point of incidence, it's get reflected in this way, or when it falls on this surface, it gets reflected in this way. Means these two rays are not parallel to each other. That is the incident ray. These are the two incident rays, and these two are the reflected rays. So the incident ray and the reflected ray are not parallel to each other. This happens in the form, in which condition? That's a irregular surface. Now let's consider the reflection of light separately of this incident wave. Suppose it's a AO and B. AO is the incident ray and OB is the reflected ray, and suppose then I is the angle of incidence and R is the angle of reflection. In the case of irregular surface also, the laws of the reflection get follows. Means what is the law of reflection? That the angle of incidence and the angle of reflections are equal. Means the angle of incidence is equal to the angle of reflection in also the irregular surface. So our first law is followed, that the angle of incidence is equal to the angle of reflection. Now what's our second law? The angle of incidence, the incident ray, the reflected ray and normal lies in the same plane. Here in the irregular surface also, the incident ray, reflected ray and normal are in the same plane. That's why the second law of reflection is also get followed. Now what's the third? That the incident ray and the reflected ray are on the opposite side of the normal. Here also in the irregular surface, the incident ray, that's the AO, and the OB reflected ray are on the opposite sides of the normal. That's the third law. That is the incident ray and the reflected ray are on opposite sides of normal. So this is the three laws of our reflection which also follows in the irregular surface. So we can say that the laws of the reflection follows in the case of the irregular surfaces also. So what we have studied till now, that's the three laws of the reflection. Now what is actually the reflection? The bouncing back or the reflection of the light from the any surface. Means the bouncing back of the incident ray or the light is nothing but the reflection of the light. For bouncing back this ray, there is some laws. That's the incident ray. That's how the Q require of the laws of the reflection. That's the angle of the incidence is equal to the angle of the reflection. This is our first law. That's the incident ray, that's the reflected ray, and the normal. These three are in the same plane. This is our second law. And what's the third? That's the incident ray and the reflected ray are on the opposite sides of the normal. This is our three law of reflection. Now this three law of reflection follows in irregular surface also. or in a regular surface. So this is nothing but the reflection of light. Now on the laws of the reflection, there are some numericals on your books. So we will solve these numericals. So we are going to discuss the problems or the numericals on the reflection of light, which are present on the page number 114. Now let's take the first problem. It is, if the reflected ray makes an angle of 60 degree with the normal, that is, the reflected ray makes an angle of 60 degree with normal, then what is the angle must the incident ray makes with the normal? Then what is the angle incident ray must makes with an normal? Now this is our question, that is the reflected ray makes an angle of 60 degree with the normal, and what is the angle of incident ray with which makes with a normal? Now let's see the diagram. We have seen this diagram before in the reflection of light, that is consider AO, P and N. Now this is the normal, and this is our incident ray, and OP, this is our reflected ray. Now what's our problem? That's a reflected ray makes an angle of 60 degree with normal. Now this is the normal and this is the reflected ray. So this is the angle of reflection which is given as at 60 degree. Now what is the angle of the incident ray? Which now the angle who makes incident ray with the normal is nothing but the same as that of the reflected angle of reflection. Now this is the angle of incidence and this is the angle of the reflection. Here we have given the angle of the reflection. Angle of the reflection means the angle which makes the reflected ray with the normal is nothing but the angle of reflection. So here we have given the 60 degree is nothing but the angle of the reflection. So according to our laws of reflection, that's the angle of the reflection is equal to the angle of the incidence. Here we have given the angle of the reflection, and what we ask, that's the angle of the incidence. So angle of incidence is equal to also the 60 degree, because angle of incidence is equal to the angle of the reflection. Now let's move towards the second problem. In second problem, if the angle between the incident ray and the reflected ray, means if the angle between incident ray and the reflected ray is 90 degree, then what is the angle of, what is the value of angle of incidence and angle of reflection? Here, what we given in the example, that's if the angle between the incident ray and the reflected ray is 90 degree. Now let's see our diagram. What is the incident ray? That this is the incident ray and OB is the reflected ray. Now what we have given, the angle between the incident ray and the reflected ray, means this whole angle is given in this problem. That's the angle between the incident ray and the reflected ray. What we have given, that is a 90 degree. So now in this angle, means this whole angle is nothing but the addition of angle of incidence and angle of reflection, because the angle of incidence and the angle of reflection is same. So we have given this the total angle. So to find out the angle of incidence and the angle of reflection, we just have to divide, that's 90 degree divided by 2, that's a 45 degree. So each angle is of 45 degree. That is angle AON plus angle NOB, which is given is 90 degree. That's angle AON means angle of incidence, plus NOB means angle of reflection, which is given as 90 degree. So we have to find the angle of incidence and the angle of reflection. But according to the first law, the angle of incidence is equal to the angle of reflection. That's why both angle becomes of the 45 degree. That is the angle between plane mirror and the incident ray. Angle between plane mirror and incident ray is of 35 degree. Then find the values of angle of incidence and angle of reflection. So in this question what we have given, that is the angle between the plane mirror and the incident ray. Now what is the plane mirror? That is the plane mirror, and this is the AO is our incident ray. So angle made by the incident ray with the plane mirror is of the 35 degree. So what we have asked, angle of the incidence and the angle of the reflection. Now this is the angle of incidence, the angle made by the incident ray with the normal, and angle of the reflection is the angle made by the reflected ray with the normal. We have asked these two angles. Now what we have given, the angle made by the incident ray with the normal. So basically we have known that the angle made by the normal with the surface is of 90 degree. Means consider this is a P. The angle NOP is of the 90 degree. Now this angle NOP is equal to angle of incidence and the angle AOP. That's the angle AOP plus angle of incidence. Means this angle and this angle combinedly form this big angle, that's a 90 degree angle. So what we have given, we have given the angle AOP, that is of the 35 degree, and angle of incidence is equal to what? 90 degree. So for angle of incidence automatically we get the value, that's 90 degree minus 35 degree is 55 degree. So we get the value of the angle of incidence, that's the angle of incidence is nothing but the 55 degree. So from first law of reflection what we have known, that the angle of incidence is equal to the angle of reflection. So what we have to find, that the angle of reflection, values of the angle of reflection and the values of the angle of incidence. We got the value of the incidence, value of the angle of the incidence, that is the 55 degree, and which is same as that of the value of the angle of reflection. So angle of the angle of incidence and the angle of reflection is 55 degree. Now let's move on the fourth problem. That is what angle will be reflected ray makes with the mirror. What angle will the reflected ray makes with the mirror if the angle of incidence is 40 degree? Now let's look at this problem. That is what is the angle will the reflected ray makes with the mirror. Now this is our reflected ray and this is our mirror. So what we have asked, that we have been asked this angle, the value of this angle. What we have given, reflected incidence. If the angle of incidence is 40 degree, we have given this angle, that's the angle of incidence is 40 degree. We have given the angle of incidence. Now we have have to find this angle. Now from the first law of reflection, what we have known? That's the angle of incidence is equal to the angle of reflection. Here the angle of incidence 40 degree. That's why the angle of reflection means this angle made by the reflected ray with the normal means this angle, that the angle of reflection is of 40 degree. Now as we look at in the previous problem, that's the angle made by the normal with the surface is of the 90 degree. Means angle NOP means this total angle, that is the angle NOP is of 90 degree. What we have, we have the angle of reflection and we have this total angle, that is 90 degree. So angle of reflection plus angle N, then angle BOP means this angle which we have been asked in the question is equal to angle NOP. So what is the angle NOP? That is 90 degree. What is the angle NOP? That is the angle of reflection, that is the 40 degree, plus the angle which we have been asked in the given question, that is the angle BOP. This is given angle, that is the angle BOP. So angle BOP is equal to 90 minus 40, that is a 50 degree. So 50 degree, what is the angle BOP? Means the angle made by the reflected ray with the normal, the angle made by the reflected ray to the surface, means the angle will reflected ray makes with the mirror. Mirror means this surface. We have been asked, and this the value of this angle is 50 degree. So these are the questions and the numericals on the reflection of light. Now what we have been studying till now, that's the reflection of the light. That's the reflection of the light. There are three laws of the reflection of the light. Now what is the light? Light is nothing but the radiation. Which radiation? Electromagnetic radiation. Now what is the electromagnetic radiation? The radiation in which the electric and the magnetic fields are perpendicular to each other. Now there are the laws of reflection. Now in the laws of reflection, only the three things are important. That is the incident ray, reflected ray, normal, the angle of incidence, and angle of the reflection. Now what are the three laws of the reflection of the light? That is the incident ray and the reflected ray are on the opposite sides of the normal. The incident ray, normal, and the reflected ray are in the same plane, and the angle of incidence is equal to the angle of the reflection. Now what is mean by the angle of incidence? The angle made by the incident ray to the normal is nothing but the angle of the incidence, and the angle made by the reflected ray to the normal is nothing but the angle of reflection. Also, while solving the numericals and the problems on the reflection of the light, you have to understand only two things. That is, the angle of incidence is equal to the angle of the reflection, and the normal makes the angle of 90 degree to the plane or to the mirror. Means this angle is 90 degree, this angle is 90 degree, and this angle of incidence is equal to the angle of reflection. These are only the basic two things we have to remember by solving the numericals and the problems on the reflection of the light. Now this is the reflection of the light.